Hi, in this video I am discussing a question related to Doppler effect. Before watching this video, it is better to watch the video in which I derive the equations for apparent wavelength and apparent frequency. The link for that video is given on the description of this video. Okay, so the question is this one. Okay, so a car A is moving towards car B at a speed 14 meter per second and it is emitting ultrasound at a frequency of 72 kilohertz. Car B is moving towards A at a speed UB. The ultrasound is reflected from car B and the reflected wave is received by car A at a frequency of 83 kilohertz. Speed of the sound in air, speed of the sound and speed of ultrasound are the same. So speed of the sound in air is 342 meter per second. The question is find the velocity UB of the car B. Okay, so in this question, both the wave source, this is the wave source, this is the observer, when the wave travels from A to B. After reflection, B becomes wave source and A becomes observer. Okay, so since initially, first when wave travels from, when sound travels from, or ultrasound travels from A to B, A is the wave source and B is the observer. Both are in motion. So since they are moving towards each other, since the car A is moving towards B, there will be change in wavelength because A is moving towards B. Okay, the derivations are shown on separate video and I put the URL or the link of that video in the description of this video, so better watch that. So here car A is going towards car B, so the frequency of the wave approaching the car B, if I say f dash, that f dash is given by C plus observer, this is the observer UB, C plus UB over C minus U source, source is A times F, F is the actual frequency, C plus US, that's the general equation, F dash equals C plus US over C minus U, C plus UO observer, C plus U over C minus US into F is the actual equation. So here when the wave travels from A to B, B is the observer, so U plus C plus UB over C minus UA, A is the wave source. Okay, so here we can substitute the values given and I can find F dash in terms of F. So F dash, we don't know what's the frequency received by, so the car B, that is F dash equals, C is given as 342 plus the speed of the car B is unknown, we need to find it. C 342 minus speed of the car is 14 into the frequency 72 kilohertz. I can give it in multiply by 1000, but anyway 72 kilohertz means this also will be in kilohertz. Okay, so when the wave reflects from B to A, reaches car A, B is going to be the wave source and A is going to be the observer. So there I can say F double dash is equal to C plus, so the car B was earlier observer, now car A is the observer. You know the equation F dash, when there's a wave, both are in motion, when there's a wave emitted, so C plus UO over C minus US into F when both are in motion. So here now, when the reflected wave approaches A, B is the wave source, A is the observer. So C plus UA over C minus UB into f dash is the frequency of the wave traveling from B to A. Okay, so I can substitute instead of f dash this one. So f double dash equal C plus UA over C minus UB into, instead of f dash, I can say 342 plus UB over 342 minus 14 into 72. So f double dash, I know that that is 83. So 83 equal 342 plus UA, that is 14 over 342 minus UB into 342 plus UB over 342 minus 14, that will be 342 minus 14 will be equal to 28 into 72. Okay, now the only unknown is UB. We need to solve this. Okay, simply we can solve it like 83 divided by 72. So this I can write 83 divided by 72 equal 342 plus 14 will be equal to 356. This is 328. 342 minus 14, 328. Okay, so 342, 356 over 328 into 342 plus UB over 342 minus UB. Okay, so simply you can solve it and you will get the answer for UB, that will be equal to 10.3 meter per second.